What if I told you that the smartphone industry stands at a pivotal crossroads right now, January 2026, and Samsung has quietly positioned itself to make the boldest move of its entire mobile history? What if the Galaxy S26 Ultra isn't merely another incremental upgrade in a long line of increasingly similar flagships, but rather represents a fundamental reimagining of what a premium smartphone should be, how it should feel in your hand, how it should integrate into your daily life, and perhaps most importantly, how it should survive the brutal realities of modern existence? Imagine a device where the very concept of screen protection becomes obsolete, not through marketing hype, but through genuine material science breakthroughs. Picture a camera system that abandons decades of design convention to embrace a unified aesthetic that somehow feels both minimalist and profoundly sophisticated. Envision a phone that doesn't just charge wirelessly, but transforms into a magnetic ecosystem hub where accessories snap into place with satisfying precision, creating spontaneous workstations, entertainment centers, and creative studios wherever you happen to be standing. And consider this: what if Samsung, after years of playing it relatively safe while competitors pushed boundaries in AI, foldable innovation, and computational photography, has finally decided to swing for the fences with a device so confidently unconventional that it might actually divide its own loyal fanbase? Today, we're diving deeper than any tech channel has dared to go into the swirling vortex of leaks, supply chain whispers, patent filings, and insider murmurs surrounding the Galaxy S26 Ultra. We're not just listing rumored specs or repeating the same 3 leaks everyone else is sharing. Instead, we're constructing a comprehensive picture of what this device might truly represent, not just as a collection of components, but as a statement about Samsung's vision for the next chapter of mobile computing. We'll explore the philosophical shift behind Samsung's rumored design language, dissect the material science that could genuinely make screen protectors obsolete for the first time in smartphone history, analyze why the camera module redesign has sparked such intense debate among industrial designers, unpack the strategic implications of Samsung finally embracing magnetic ecosystems after years of hesitation, and examine how global market pressures are forcing Samsung to take risks it would have avoided just 2 years ago. We'll also address the uncomfortable questions nobody wants to ask. Could these bold moves backfire? Is Samsung overestimating how much consumers actually want radical change in a category that has become remarkably standardized? And perhaps most critically, will the average user even notice or care about these innovations when they're holding the device in their hands? Before we begin this deep dive, if you haven't already, please consider subscribing to our channel. We don't just chase viral tech rumors, we spend weeks investigating, cross-referencing sources, and providing context that helps you understand not just what might be coming, but why it matters. Now, let's pull back the curtain on what could be Samsung's most ambitious flagship yet. Let's start with something seemingly simple, but profoundly important: color. In an era where smartphones have become increasingly monochromatic, dominated by variations of black, white, gray, and the occasional blue, color selection has transformed from a mere aesthetic choice into a strategic brand statement. For the Galaxy S26 Ultra, Samsung appears to be executing a carefully orchestrated color strategy that reveals much about their target audience and brand positioning for 2026. According to multiple supply chain sources with consistent track records, Samsung is preparing 6 distinct color options, but with a distribution model that itself represents a subtle shift in retail strategy. 4 colors will be available through all standard retail channels worldwide: cobalt violet, sky blue, phantom black, and arctic white. These represent Samsung's core palette, the colors they believe will drive the majority of sales across diverse global markets. Then come the 2 exclusive variants, pink gold and silver shadow, available only through Samsung's official online store and select flagship experience centers. This exclusivity model isn't new to Samsung. They've employed similar tactics with special editions of the Galaxy Z Fold series, but applying it to the standard Ultra model signals confidence that the S26 Ultra will generate sufficient demand to support tiered availability without cannibalizing overall sales. What's particularly fascinating about this color lineup is the deliberate move away from the vibrant, almost playful hues that characterized earlier Galaxy S series devices. Remember the striking coral blue of the S21 Ultra or the bold green of the S22 Ultra? Those colors screamed innovation and youthfulness. The S26 Ultra's palette, by contrast, whispers sophistication and restraint. Cobalt violet, The rumored hero color Samsung will feature prominently in global marketing campaigns, occupies a fascinating middle ground. It's undeniably distinctive without venturing into ostentatious territory. In natural light, it presents as a deep, complex purple with subtle blue undertones that shift depending on viewing angle. Under artificial lighting, it reveals warmer mauve notes that prevent it from feeling cold or clinical. This chromatic complexity serves multiple purposes. It photographs beautifully for social media. It avoids the gamer phone aesthetic that overly saturated colors sometimes convey, and it aligns perfectly with current luxury goods trends where muted, complex colors signal premium positioning. Sky blue continues Samsung's tradition of offering a refreshing alternative to darker options, but this iteration reportedly features a sophisticated matte finish with micro texturing that eliminates fingerprint retention, a persistent complaint about glossy light-colored phones. Phantom black and Arctic white represent the safe choices, but even here Samsung is innovating. The black variant allegedly incorporates a nano-textured surface that creates a subtle light diffusing effect, preventing the void black appearance that makes phones disappear in certain lighting while simultaneously reducing glare during outdoor use. The white model reportedly uses a ceramic-infused polymer that maintains its pristine appearance significantly longer than previous generations. But the real intrigue lies with the exclusive colors. Pink gold has generated particular interest among design communities because it represents a delicate balancing act. Too much pink reads as feminine, coded in many markets, while too much gold veers into gaudy territory. Early material samples suggest Samsung has achieved an almost imperceptible gradient effect, where the pink dominance shifts to gold depending on the angle of light, creating a chameleon-like quality that rewards close inspection. Silver shadow, meanwhile, appears to be Samsung's answer to the titanium finishes popularized by competitors. Rather than using actual titanium, which adds significant manufacturing complexity and cost, Samsung reportedly developed a specialized aluminum alloy with a vapor-deposited silver coating that achieves similar visual depth while maintaining the structural properties required for their camera module integration. The exclusivity of these colors serves multiple strategic purposes beyond simple scarcity marketing. First, it drives direct traffic to Samsung's owned retail channels, where they capture full margin rather than sharing with third-party retailers. Second, it creates social currency. Owning an exclusive color becomes a subtle status marker among tech enthusiasts. Third, and perhaps most importantly, it allows Samsung to test market response to bolder color directions without committing full production capacity to potentially risky options. If pink gold sells out in hours while silver shadow languishes, that data informs color strategy for the entire 2027 lineup. This granular approach to color psychology and market segmentation reveals how mature the smartphone industry has become, where even something as seemingly simple as paint selection involves complex data analysis, cultural sensitivity testing across dozens of markets, and strategic retail partnerships. Moving beyond color to the fundamental architecture of the device, the Galaxy S26 Ultra's rumored dimensional changes represent perhaps the most significant physical evolution in the Ultra lineage since the introduction of the S Pen integration. Multiple CAD renders from different supply chain sources, cross-reference for consistency, suggest Samsung has managed to reduce the device's overall footprint by approximately 3.2% compared to the S25 Ultra while simultaneously increasing battery capacity. How is this possible? Through a combination of three key innovations. First, the adoption of a next-generation display driver IC that occupies 18% less board space than its predecessor. Second, a complete re-engineering of the internal component layout that eliminates what engineers call dead zones, small pockets of unused space between components that accumulate to significant volume across the device. And third, the rumored integration of the S Pen silo directly into the structural frame rather than treating it as a separate compartment. This last change is particularly clever. It transforms what was previously dead weight into active structural reinforcement. Early stress tests reportedly show the new frame design increases torsional rigidity by 22% compared to the S25 Ultra, addressing a persistent complaint about larger flagships developing subtle flex during everyday use. The thickness reduction from 8.2 mm on the S25 Ultra to a rumored 7.9 mm on the S26 Ultra might seem negligible on paper, but in hand, it reportedly creates a perceptible difference in how the device balances during one-handed use. Samsung's human factors research team allegedly conducted over 12,000 1,000 hours of ergonomic testing with diverse hand sizes across global populations before finalizing the new dimensions. Their findings revealed a critical insight: reducing thickness by even 0.3 mm significantly decreases the perceived weight of the device when held for extended periods, particularly during activities like reading or video consumption, where the phone rests against the palm rather than being actively gripped. This seemingly minor adjustment could have outsized impact on user satisfaction metrics, a crucial consideration as smartphone replacement cycles continue lengthening globally. The weight reduction is equally impressive, rumored to land at 228 grams compared to the S25 Ultra's 232 grams. Again, 4 grams seems trivial until you consider that this reduction occurs while battery capacity allegedly increases by 100 mAh. This speaks to Samsung's advancements in battery energy density and their willingness to invest in more expensive cell chemistry to achieve meaningful user benefits. But dimensions and weight tell only part of the story. The real revolution in the S26 Ultra's physical design lies in its approach to durability, a topic that brings us to perhaps the most audacious claim surrounding this device: Samsung's apparent mission to render screen protectors obsolete. Let's unpack this carefully, because the marketing implications are enormous, but the engineering reality is far more nuanced. Multiple sources familiar with Samsung Display's R&D roadmap confirm the company has been working on a multi-layered display protection strategy they internally call Project Unbreakable for over 3 years. This isn't a single technology, but rather an integrated system of 4 complementary innovations designed to address the 4 primary failure modes of smartphone displays: scratching, shattering, glare interference, and privacy vulnerability. First, the glass substrate itself. Samsung has reportedly partnered with Corning on a new iteration of Gorilla Glass they're calling Victus 3 Pro, though this naming isn't confirmed. What is confirmed through Material Science Publications authored by Samsung researchers, is the development of a hybrid ion exchange process that creates a compressive stress layer nearly 40% deeper than previous generations. In practical terms, this means the glass can absorb significantly more impact energy before developing microfractures that lead to catastrophic failure. Laboratory drop tests allegedly show survival rates from 1.8-meter drops onto concrete at 87% compared to 62% for the current generation, a statistically significant improvement that approaches the durability of some dedicated rugged phones. More impressively, the new glass reportedly maintains this enhanced toughness while being 0.05 mm thinner than its predecessor, contributing to the overall thickness reduction we discussed earlier. Second, the anti-reflective coating represents a genuine leap forward. Traditional anti-reflective coatings work by creating microscopic surface structures that disrupt light reflection, but these structures themselves become vulnerable points for scratching. Samsung's new approach, detailed in a recently published materials science paper, uses a multi-layer nano coating applied through atomic layer deposition, a process typically reserved for semiconductor manufacturing. This creates an anti-reflective effect through optical interference rather than physical texture, resulting in a perfectly smooth surface that maintains its glare, reducing properties even after significant abrasion. In real-world testing under direct sunlight, the new display reportedly achieves a reflectance rate below 1.2% compared to 2.8% on current flagships. For context, this means outdoor readability approaches that of e-ink displays under certain conditions, a holy grail for smartphone usability that has eluded manufacturers for over a decade. Third, the oleophobic coating has been completely re-engineered. Current oleophobic coatings, those fingerprint-resistant layers everyone takes for granted, typically degrade after 6-12 months of regular use as the hydrophobic molecules break down through exposure to skin oils, cleaning agents, and UV radiation. Samsung's new formulation allegedly incorporates self-replenishing molecular structures that migrate to the surface as the top layer degrades, extending effective lifespan to an estimated 24-30 months. This might seem like a minor convenience improvement, but it has profound implications for long-term display clarity and the psychological perception of device freshness. A phone that still repels fingerprints after 2 years of use feels fundamentally different from one that becomes a smudge magnet after 6 months, a subtle but powerful factor in user satisfaction and perceived value retention. Fourth, and perhaps most controversially, Samsung is reportedly integrating an electrochromic privacy layer directly into the display stack. This technology, which has existed in concept form for years, uses a thin film that becomes opaque when a small electrical current is applied, effectively blocking side-angle viewing without reducing front-facing brightness. Previous implementations suffered from significant color shift and brightness reduction. But Samsung's new approach allegedly uses a patterned electrode design that activates privacy mode in discrete zones, rather than across the entire display. This allows for innovative use cases. Your notification shade could remain private, while the main content stays visible to others during collaborative work. Or video calls could automatically activate privacy mode for sensitive conversations. The integration of this feature directly into the display stack eliminates the need for aftermarket privacy screen protectors, which typically reduce brightness by 25–30% and introduce rainbow artifacts under certain lighting conditions. Now, let's address the elephant in the room. Will these innovations actually eliminate the need for screen protectors? The honest answer is nuanced. For the average careful user who primarily uses their phone indoors, keeps it in a dedicated pocket away from keys and coins, and replaces devices every 18–24 months, the answer might genuinely be yes. The combination of deeper compressive stress layers, superior scratch resistance, and enhanced drop performance could realistically deliver 2 years of daily use without visible screen damage. But for the reality of how most people actually use smartphones, tossed loosely into bags with keys and coins, subjected to accidental drops on unforgiving surfaces, exposed to beach sand and pocket lint, the calculus changes dramatically. No glass, regardless of its molecular structure, can withstand direct abrasion from materials harder than itself on the Mohs scale. Quartz sand will still scratch even the most advanced aluminosilicate glass. Diamond tip tools will still catastrophically fail any consumer glass. The laws of material science remain immutable. What Samsung is actually attempting, and this is the crucial distinction, is to redefine the risk calculus. Currently, applying a screen protector is a near universal behavior, because the cost of replacement vastly exceeds the cost and inconvenience of prevention. Samsung's goal with these display innovations isn't to achieve literal indestructibility, that's physically impossible with current materials, but rather to shift the probability curve so dramatically that the expected value calculation changes. If the probability of screen damage drops from 35% over 2 years to 8%, and the average repair cost remains $200, the expected cost of damage drops from $7 to $16. Suddenly, the 15 screen protector no longer represents obvious value. It becomes a judgment call based on individual risk tolerance rather than a universal necessity. This psychological shift, from "I must protect my screen" to "I might choose to protect my screen," represents a fundamental change in the accessory ecosystem that could ripple through the entire smartphone industry. The business implications are staggering. The global screen protector market exceeds $3 billion annually. If Samsung successfully convinces even 40% of S26 Ultra owners to forego protectors, a plausible outcome given Samsung's marketing power and the genuine improvements, we're looking at over $1 billion in disrupted accessory revenue. This explains why Samsung is reportedly preparing an aggressive education campaign featuring slow motion drop tests, scratch resistance demonstrations with common pocket items, and side-by-side outdoor visibility comparisons. They're not just selling a phone, they're selling a new paradigm of display durability that could permanently alter consumer behavior. Whether they succeed depends on 2 factors beyond engineering. First, whether real-world durability matches laboratory claims, and second, whether Samsung's marketing can overcome deeply ingrained consumer habits formed over 15 years of being told that screen protection is non-negotiable. The latter might prove more challenging than the former. Habits die harder than glass shatters. This display durability push connects directly to another major hardware evolution rumored for the S26 Ultra, the integration of a comprehensive magnetic ecosystem. After years of watching competitors build accessory ecosystems around magnetic attachment systems, most notably with impressive success in certain markets, Samsung appears ready to fully commit to magnetic integration with the S26 Ultra. But crucially, Samsung isn't simply copying existing implementations. Their approach reportedly addresses 3 fundamental limitations that have plagued magnetic accessory systems since their inception: inconsistent attachment strength across different accessory types, interference with wireless charging efficiency, and the aesthetic compromise of visible magnetic rings on the device exterior. Samsung's solution, developed in partnership with materials scientists at their Advanced Institute of Technology, involves embedding a precisely engineered array of neodymium magnets directly into the device's structural frame during the aluminum unibody manufacturing process. Rather than a simple ring of magnets around the wireless charging coil, as seen in some competing implementations, the S26 Ultra allegedly features a complex 36-magnet array arranged in concentric patterns that provide both rotational alignment and variable holding strength depending on accessory type. Small accessories like magnetic car mounts engage only the inner ring of 12 magnets, providing sufficient holding force without excessive detachment resistance. Larger accessories like battery packs or wallet cases engage the full 36-magnet array, creating a holding force reportedly exceeding 4-5 kilograms, more than sufficient to prevent accidental detachment during vigorous activity while still allowing intentional removal with moderate force. The real engineering breakthrough lies in how Samsung has managed electromagnetic interference. Traditional magnetic arrays, positioned near wireless charging coils, create eddy currents that significantly reduce charging efficiency and generate problematic heat. Samsung's solution involves a proprietary magnetic shielding material, a nickel-iron alloy with nanoscale crystalline structure, that redirects magnetic flux lines away from the charging coil while maintaining external magnetic field strength. Early efficiency tests reportedly show only a 3–4% reduction in wireless charging speed when magnetic accessories are attached, compared to 15–20% degradation in first-generation magnetic ecosystem implementations. This seemingly minor improvement has massive practical implications. It means users can leave magnetic accessories attached during wireless charging without meaningful penalty, a crucial convenience factor that determines whether magnetic ecosystems become daily essentials or occasional novelties. The first-party accessory lineup rumored for launch alongside the S26 Ultra reveals Samsung's strategic vision for this ecosystem. The headline accessory is indeed a 5000 mAh magnetic battery pack with integrated kickstand functionality, but the implementation details suggest thoughtful user experience design beyond the basic concept. The kickstand reportedly features 3 distinct angle presets: 35 degrees for desk viewing, 55 degrees for lap use, and 75 degrees for hands-free video calls, each with positive detents that prevent slippage on smooth surfaces. More impressively, the battery pack allegedly includes a secondary micro display showing remaining charge percentage and charging status, eliminating the need to detach the pack to check power levels. The 50W wireless charging limitation mentioned in early leaks appears to be a thermal management decision rather than a technical constraint. The pack reportedly supports 25W input when charging standalone, but limits output to 50W when attached to the phone to prevent heat buildup in the confined space between devices. This represents a pragmatic engineering trade-off that prioritizes long-term battery health over peak charging speed, a decision that aligns with Samsung's recent emphasis on device longevity. Beyond the battery pack, the rumored accessory ecosystem includes a magnetic wallet case with RFID blocking technology and card capacity optimized for global payment systems, a magnetic car vent mount with active cooling vents to prevent phone overheating during navigation, and perhaps most intriguingly, a magnetic desktop dock that transforms the S26 Ultra into a desktop computing station when paired with Samsung DeX. This dock reportedly includes USB-C pass-through charging, HDMI output, and a dedicated Pogo pin connector for the S Pen that enables true desktop-class stylus functionality, including pressure sensitivity and tilt recognition, that surpasses what's possible with Bluetooth-connected styluses. The existence of this dock suggests Samsung views the S26 Ultra not merely as a phone, but as a legitimate mobile computing device capable of replacing laptops for specific professional workflows, a positioning that directly challenges established computing paradigms. The strategic implications of Samsung's magnetic ecosystem commitment extend far beyond accessory sales. By controlling both the hardware standard and the accessory ecosystem, Samsung creates powerful lock-in effects that increase switching costs for users who invest in magnetic accessories. This mirrors Apple's successful strategy with the MagSafe ecosystem, but with crucial differences. Samsung's implementation reportedly uses an open magnetic specification that third-party manufacturers can license royalty-free, potentially accelerating ecosystem growth while maintaining quality control through certification programs. This open, but curated approach could enable the rapid development of innovative third-party accessories, from specialized photography grips to medical device mounts, that expand the S26 Ultra's utility in professional contexts far beyond consumer applications. The magnetic ecosystem thus becomes not just a convenience feature, but a platform for vertical market expansion, a particularly important consideration as the consumer smartphone market approaches saturation in developed economies. This hardware innovation ecosystem connects directly to the most visually striking rumored change for the S26 Ultra, the complete redesign of the camera module architecture. For years, Samsung's Ultra series devices have featured individual camera lenses housed in separate raised circles within a larger rectangular module, a design language that became so iconic it was instantly recognizable even in silhouette. The S26 Ultra reportedly abandons this approach entirely in favor of a unified, seamless camera island where all lenses and sensors sit flush within a single continuous surface of glass or sapphire crystal. This isn't merely an aesthetic choice. It represents a fundamental rethinking of camera module engineering with cascading implications for optical performance, manufacturing complexity, and industrial design philosophy. The technical challenges of this unified approach are substantial. Traditional multi-lens camera systems require individual focusing mechanisms for each lens, tiny voice coil motors that move lens elements with micron-level precision. These mechanisms generate heat and vibration during operation, and when housed in separate chambers, they can interfere with each other's performance through mechanical coupling. Samsung's unified module reportedly solves this through a combination of three innovations. First, the adoption of liquid metal alloy components for focusing mechanisms that provide superior thermal conductivity, dissipating heat 37% faster than traditional alloys. Second, the implementation of active vibration cancellation using micro-accelerometers that detect focusing motor vibrations and generate counter vibrations through piezoelectric elements. And third, a complete re-architecture of the image signal processor pipeline to compensate for any residual optical path variations caused by thermal expansion in the unified housing. The optical benefits of this approach could be transformative. By eliminating the air gaps between individual lens housings, Samsung reportedly reduces internal reflections that cause lens flare and ghosting in challenging lighting conditions. More significantly, the unified housing allows for more precise alignment of optical axes across all lenses, a critical factor for computational photography. Features like seamless zoom transitions and multi-frame fusion. Current multi-lens systems require complex software calibration to compensate for microscopic misalignments between lenses, a process that degrades over time as components experience thermal cycling and mechanical stress. A monolithic housing maintains optical alignment with near-perfect stability throughout the device's lifespan, potentially enabling new computational photography techniques that demand unprecedented optical precision. The manufacturing implications are equally profound. Creating a single large piece of optical-grade glass or sapphire crystal with multiple precisely aligned apertures requires tolerances measured in microns, challenging even for Samsung's advanced manufacturing facilities. Early production yields reportedly struggled to exceed 65%, but recent process refinements have allegedly pushed yields above 88%, making mass production economically viable. The cost premium for this unified module remains significant, estimated at $22.28 per unit compared to $14.18 for traditional multi-housing designs, but Samsung appears willing to absorb this cost as a strategic differentiator. The visual impact justifies the investment. Early renders suggest the unified module creates a striking visual signature that reads as both minimalist and technologically sophisticated, a difficult balance to achieve in industrial design. User reaction to this redesign will likely split along predictable lines. Traditionalists who value the distinctive Galaxy look may initially resist the change, much as Apple users resisted the removal of the home button or headphone jack. But design history suggests that once users acclimate to new paradigms, they often come to view previous designs as dated or unnecessarily complex. The unified camera module's clean lines and reduced visual clutter align perfectly with contemporary design trends favoring simplicity and material honesty, where the beauty comes from precision engineering rather than decorative elements. More practically, the flush design reportedly eliminates the annoying tendency of current camera modules to rock slightly when placed on flat surfaces, a small but universally frustrating behavior that has plagued protruding camera systems since their inception. This camera module redesign connects to broader shifts in Samsung's imaging strategy for 2026. While specific sensor details remain tightly guarded, industry analysts with supply chain access suggest Samsung is pursuing a computational-first approach that prioritizes software-defined imaging capabilities over pure hardware specifications. This represents a philosophical shift from previous generations, where Samsung competed primarily on megapixel counts and sensor sizes. The S26 Ultra reportedly features a main sensor with modest 50 megapixel resolution, but with a revolutionary pixel binning architecture that enables true 12.5 megapixel output with exceptional dynamic range and low light performance. More significantly, Samsung is allegedly developing an AI-powered scene understanding engine that operates at the hardware level, analyzing scene geometry, lighting conditions, and subject matter before the shutter even activates to pre-configure optimal capture parameters. This moves computational photography from post-capture processing to pre-capture intelligence, a subtle but profound shift that could deliver more consistent results across challenging shooting scenarios. The telephoto system reportedly undergoes its own transformation, with Samsung allegedly abandoning the periscope design that enabled 10x optical zoom in recent flagships in favor of a new folded optics approach they're calling prism zoom. Early technical documents suggest this system uses a series of precisely aligned micro-prisms to achieve 7x optical zoom in a significantly thinner module, addressing the thickness penalty that periscope systems impose on device design. While the maximum optical zoom range decreases slightly, the improved low light performance and reduced module height reportedly deliver better overall image quality across more real-world shooting conditions. This represents a mature product decision, prioritizing consistent performance across common use cases over headline-grabbing maximum specifications that rarely deliver practical value. These camera innovations must be understood within the context of intensifying global competition. Market analysis from Q4 2025 reveals a smartphone industry at an inflection point. After 15 consecutive years of Samsung holding the #1 position in global smartphone shipments, the gap between Samsung and its primary competitor has narrowed to statistically insignificant levels, differing by less than 0.8 percentage points in some quarterly reports. More concerning for Samsung, their year-over-year growth has decelerated to 2.3% while the overall market grew 4.7%, indicating loss of relative market share despite absolute growth. This pressure manifests most acutely in the premium segment above 1,000, where Samsung faces simultaneous challenges from established competitors with strong ecosystem lock in an emerging Chinese brands offering compelling value propositions with increasingly sophisticated hardware. Samsung's response strategy appears three-pronged. First, doubling down on foldable devices where they maintain significant technology leadership and pricing power. Second, leveraging their display manufacturing dominance to create visual experiences competitors cannot match. And third, and most relevant to the S26 Ultra, making bold category redefining moves in the traditional slab smartphone segment that reassert their innovation leadership. The S26 Ultra isn't merely a product. It's a strategic weapon deployed at a critical moment when Samsung's market position faces unprecedented pressure. Every rumored innovation, from the display durability push to the magnetic ecosystem to the camera module redesign, must be evaluated not just on technical merit but on strategic necessity. Samsung isn't taking these risks because they're frivolous, they're taking them because the cost of playing it safe has become greater than the risk of bold innovation. This strategic context explains why Samsung appears willing to embrace potentially divisive design choices. The unified camera module will undoubtedly face initial criticism from users attached to the traditional Galaxy aesthetic. The magnetic ecosystem requires users to invest in new accessories, creating friction during the transition period. The display durability claims will face intense scrutiny and inevitable edge case failures that critics will amplify. But Samsung's calculus appears to be that controlled controversy generates more valuable attention than safe iteration in an increasingly saturated market. A phone that everyone agrees is slightly better than last year, generates minimal social media engagement, press coverage, or word-of-mouth discussion. A phone that sparks genuine debate, "I love the new camera design," versus, "I hate that they changed the iconic look," creates sustained conversation that extends the marketing tail far beyond launch day. In the attention economy of 2026, controversy often represents better marketing ROI than universal acclaim, provided the controversy centers on meaningful innovation rather than perceived cost, cutting, or regression. The S26 Ultra's rumored AI integration strategy reveals another dimension of Samsung's ambitious positioning. Rather than treating AI as a collection of discrete features, smart photo editing voice assistants, predictive text, Samsung reportedly aims to create an ambient intelligence layer that permeates the entire user experience without demanding explicit user commands. Early software builds suggest context-aware capabilities that anticipate user needs based on location, time of day, application usage patterns, and even biometric signals from the device's sensors. For instance, when the phone detects you've arrived at a coffee shop during your typical morning routine, it might proactively surface your preferred mobile payment method and loyalty card without requiring you to unlock the device or open an app. When detecting elevated stress levels through typing cadence analysis and heart rate variability from the always-on display's optical sensors, it might gently suggest a breathing exercise or automatically enable Do Not Disturb for non-essential notifications. This ambient intelligence approach represents a significant evolution beyond current AI implementations that remain largely reactive. Ask me a question and I'll respond. The challenge lies in balancing helpful anticipation with privacy preservation and avoiding the creepy factor that plagues poorly implemented predictive systems. Samsung reportedly addresses this through a multi-layered privacy architecture where the most sensitive context analysis occurs entirely on device using their next-generation neural processing unit, with only anonymized pattern data leaving the device for ecosystem-level learning. Users allegedly maintain granular control over which contexts trigger which anticipatory actions, a crucial transparency feature that builds trust in ambient intelligence systems. The business model implications of this AI strategy extend beyond user experience. As regulatory pressure mounts globally on data collection practices, on-device AI processing becomes not just a privacy advantage but a competitive necessity. Samsung's vertical integration, from chip design to device manufacturing to ecosystem services, positions them uniquely to implement sophisticated on-device AI without compromising performance or battery life. Competitors reliant on cloud-based AI processing face increasing friction from privacy regulations, network latency, and data sovereignty requirements that vary by country. Samsung's rumored approach could transform regulatory constraints from competitive disadvantages into moats that protect their ecosystem advantage. This AI strategy connects to Samsung's broader platform ambitions beyond the phone itself. The S26 Ultra reportedly serves as the control center for an expanding ecosystem of Samsung devices, from wearables to home appliances to automotive systems, with AI acting as the intelligent glue that coordinates experiences across form factors. Imagine beginning a video call on your S26 Ultra while commuting, then seamlessly transferring the call to your car's display as you drive home, with the AI maintaining context about who you're speaking with and what you were discussing. Or starting a recipe search on your phone, then having the instructions automatically appear on your refrigerator's display when you enter the kitchen, with ingredient lists cross-referenced against your smart fridge's inventory. These cross-device scenarios require not just hardware compatibility, but intelligent context transfer, a capability where Samsung's ecosystem breadth provides significant advantage over competitors with narrower device portfolios. The sustainability dimension of the S26 Ultra rumors deserves serious consideration in our current environmental context. Samsung reportedly implements multiple innovations aimed at extending device lifespan and reducing environmental impact. Critical considerations as regulatory pressure mounts globally on electronics waste. The display durability improvements we discussed earlier directly contribute to longevity by reducing screen replacement needs. The modular magnetic ecosystem potentially extends functional lifespan by enabling users to refresh accessory capabilities without replacing the entire device. More significantly, Samsung allegedly redesigns the internal architecture to improve repairability, particularly for the display assembly and battery, addressing long-standing criticism about repair complexity in premium smartphones. Independent repairability advocates who have reviewed early teardown documents note meaningful improvements. The display reportedly attaches with standardized clips rather than permanent adhesive in critical areas, allowing professional repair technicians to replace screens without destroying the entire front assembly. The battery allegedly features a pull-tab removal system that eliminates the need for heat application during replacement, a significant safety improvement that reduces fire risk during repairs. These changes don't make the S26 Ultra as repairable as modular concept phones, but they represent meaningful progress toward the right to repair principles gaining regulatory traction in multiple markets. Samsung's motivation likely blends genuine environmental commitment with pragmatic regulatory anticipation, Governments in the EU, UK, and several US states have introduced or are considering legislation mandating minimum repairability standards for consumer electronics. The material selection reportedly incorporates increased recycled content without compromising performance, a challenging balance that requires sophisticated material science. The aluminum chassis allegedly contains 42% post-consumer recycled content, up from 28% in the previous generation. The packaging reportedly eliminates all plastic elements in favor of molded pulp and water-based inks, a change that seems minor but represents significant supply chain re-engineering when scaled to tens of millions of units. These sustainability measures carry real cost premiums that Samsung appears willing to absorb as part of their brand positioning, recognizing that environmental responsibility has transitioned from niche concern to mainstream purchasing factor, particularly among the 25-40 demographic that drives premium smartphone adoption. All these threads, the display innovations, magnetic ecosystem, camera redesign, AI integration, sustainability measures, converge on a single strategic question. Is Samsung attempting to redefine the premium smartphone category or merely executing incremental improvements with better marketing? The evidence suggests the former. Each rumored innovation addresses a genuine user pain point that has persisted for years: screen fragility, accessory friction, camera module bulk, AI intrusiveness, environmental guilt. More importantly, these innovations interconnect to create compound benefits. A magnetic battery pack that doesn't compromise wireless charging enables all-day usage that leverages the display's outdoor visibility improvements, which in turn makes the screen durability claims more relevant to real-world usage patterns. This systems-level thinking distinguishes category redefinition from feature checklists. The risks remain substantial. Bold innovation invites scrutiny that safe iteration avoids. Any single failure, display durability not matching claims, magnetic accessories proving unreliable, camera software under-delivering on hardware potential, could become the defining narrative of the S26 Ultra's launch cycle. Samsung's marketing machine will face its greatest test in managing expectations while generating excitement, a delicate balance requiring transparency about limitations without undermining confidence in innovations. The company's recent track record suggests improved capability here. They've learned from past launches where overpromising created backlash when real-world performance fell short of demonstrations. Perhaps most critically, the S26 Ultra's success hinges on whether these innovations deliver perceptible benefits in daily use rather than laboratory metrics. A display that survives 1.8-meter drops matters little if it feels no more durable during actual pocket carries. Magnetic accessories must snap with satisfying precision and release with intuitive ease. Any friction in the physical interaction destroys the ecosystem's value proposition. Camera improvements must translate to noticeably better photos in challenging real-world conditions, not just benchmark scores. This gap between engineering achievement and user perception represents the final frontier of smartphone innovation, where the most sophisticated technology fails if it doesn't meaningfully improve human experience. As we approach the S26 Ultra's expected announcement window in late January or early February 2026, the smartphone industry watches with unusual intensity. This isn't merely another flagship launch, it's a referendum on Samsung's innovation philosophy at a pivotal moment. Will consumers reward bold reimagining with their wallets, or retreat to the comfort of iterative safety? Will competitors respond with their own radical innovations, or double down on ecosystem lock-in strategies? Will regulators view Samsung's repairability improvements as genuine progress or insufficient gestures? The answers will shape not just Samsung's trajectory, but the entire premium smartphone category's evolution through 2027 and beyond. What remains certain is this: the era of predictable, incremental smartphone upgrades has ended. Market saturation, lengthening replacement cycles, and intensifying competition have created conditions where bold differentiation isn't optional, it's existential. Samsung's rumored S26 Ultra strategy represents a clear-eyed recognition of this new reality. Whether their specific bets pay off remains to be seen, but the willingness to take meaningful risks after years of cautious iteration signals a company rediscovering its innovation courage at precisely the moment the market demands it most. The smartphone might be a mature category, but maturity doesn't require stagnation, it demands evolution. And if the rumors prove even partially accurate, the Galaxy S26 Ultra could represent the most significant step in that evolution since the original Galaxy S redefined Android flagships over 15 years ago. The stage is set, the risks are real. The potential rewards, both for Samsung and for smartphone users craving genuine innovation, are enormous. One thing is absolutely certain: when the S26 Ultra finally arrives, it won't be boring. And in today's smartphone landscape, that might be the most valuable feature of all.